very good business for our company. So the counties that I'm going to talk about are Trempeleau County, which is right along the Mississippi River, and Minneapolis-St. Paul is up here, and Columbia County, which one of our shops is located in that county, and that'll be the other county I'm talking about. Of course, up here we got the home of the Green Bay Packers, and we had a good year. Things didn't go quite as well. Didn't get that second Super Bowl in a row, but we did beat the Bears 4 times in the same calendar year. So the season was not a total write-off. All right, so our suppliers, in general, our company philosophy is we like to pick suppliers that are preferably number 1 or number 2 in the market, so we can be sure they're going to be around in 10 years as we maintain the system. And as a philosophy, there's different philosophies on how to do simulcast. The philosophy that I like to use is to pick components that are phase stable and amplitude stable over time, and they stay that way. And then the main variable you deal with is link delay, and then have that be automatically adjusting. So in choosing a radio, we use, in this particular project, Motorola Quantars. My own belief is that if you want to do simulcast, you should use a radio that the manufacturer uses in their simulcast system, because they have to design that radio to have the same phase response and amplitude response over time, over production, over software releases. And you get that with the Motorola Quantar product. We use a Harris Interplex SynchroCast3 system, which has worked excellent for us. And basically that's a T1 based system. They also have an IP based MUX, which is exactly the same multiplexer except with an IP card instead of a T1 card. And that automatically takes care of any changes in the link delay. What you see here in black up here are differences in systems from previous systems that I've talked about in previous years. This year we started using the Harris VF40 module. And the VF40 module is specially designed for simulcast systems. It basically is like one of their VF25 cards, but instead of passing a telephony 300, 3000 hertz, it passes 5 to 3000 hertz. So that way you can pass along either PL or DPL in Motorola terms along all the way to the site and actually generate the PL at your source site instead of generating it individually at each site and trying to mix it in. We use Aviat TruePoint, and lately we started using the Eclipse product, and that's worked out real good. We use GE MDS Leader product, the Raytheon Voters, Spectracom Master Oscillators, TXRX filtering. We're very big into making sure that all of our systems are completely properly designed with TXRX filtering, which we have their engineering department do for us. RF antennas and cables. And these are the main 2 changes we made in systems, starting these last 2 systems in this past year. First is the Convex 2240A 2C, which indicates it actually has inside of it 2 PL CTCSS generators actually in the box. You can generate your PL, and that does include the phase reversal for so you don't get the squelch tail at the end. And then another new product that's come out is the NBL4 narrowband booster limiter, and I'll talk in a little bit how that's specifically used in this system. So first I'd like to go over the system in Trempeleau County. This is was the one near the Mississippi River. This is a very rough terrain county. The southwest portion of Wisconsin sort of got missed by the glacier that hit the rest of the Midwest. And so the terrain is actually a little bit rough. And as a result, some of these microwave paths are a little bit unconventional. Instead of having a typical star type configuration, or you don't really have a good chance at a loop. The terrain's just too tough to do that. So this is how our microwave links end up. Most of our sites are co-located with towers by US Cellular, which is one of the major cell players in our part of the country. This is a coverage plot, and coverage plots can be done in many different ways, but in general, it shows a forward link. I do coverage plots a little bit like a stoplight. Gray is really good, green is good, yellow's okay. If you're starting to see, or light green is okay. Yellow and red you start to worry about. So this is the forward link, and this is the reverse link. I think about 3 years ago, I gave a presentation on how to use software from RadioSoft. This particularly uses ComStudy 2.2. This supplier is at the show, and how to use the Simulcast time delay feature of his software. He has good software, but generally the instructions are a little bit, you sort of have to figure some of the stuff out. And I ask you, if you want to go back, reference Simulcast Forum 12 and find that presentation, because this is based directly on that. And what this shows, what this is going to try to show, is how the simulcast works. And here, in this particular thing, it's in blue. And as I step back and forth, it'll show before and after. So if we start before, what we have is all the sites launch at the same time. And then if you follow the procedure, and we put in here, this is the different parameters. Basically what shows in blue is any time the time delay is more than 60 seconds and the signal strength is less than 10 dB relative from one signal to the other. Then you can go and you can change the launch times, one site relative to the other. And then this program will show you the before and after. And the next county is a little more dramatic than this, but I found since we started doing this, you can make a beautiful sounding system. As long as you don't have one site hopping over the other one, you can. It really makes a difference if you're able to offset your launch time. So I recommend this method, and you can never figure this stuff out on your own without the software like this. So picture the main site. Showing the Raytheon boulders, the Harris Interplex. Down here you have the convex control. This particular box is very nice, does everything you want to control the system. The switches are lit as they go up and down. This is the NBL4 narrowband booster. Columbia County, Wisconsin. This particular county is about 750 square miles. A little bit of rough terrain over here, otherwise the county is relatively flat. And this is mostly a star configuration for the microwave. We have one sort of odd one here. This goes back here, and this is basically backhauls on one of the state microwaves back to this site all the way over here. Otherwise it's pretty much a standard star configuration. And again, we have a forward link and then reverse link plots. And then here we start with our simulcast optimization. So normally in analog, 60 microseconds is somewhat of a standard figure to look at, where you start to notice at high frequencies, you start to notice a simulcast type effect, especially on pages. And this is what it's like with no offset. In other words, all the sites launch at the same time. And here's what it looks like if you optimize the offset. And in this particular county, the main site over here does cover a wide area, so basically you have to delay the launch of some of the other sites in order to get it to work like that. So if you take your before and your after, and what you see in this part here is this is all hills. This is all hills. There really aren't any roads or something. You're seeing the sides of the hills here, and that's why you see that kind of effect. But this is all flat over here, and pretty much you've got rid of all the simulcast effects by doing that. So the system design improvements we've made over previous designs. Previously, we basically used the Spectracom oscillator and then generated the tones at each site. And then we made our own audio splitter, and we made our own switching system to basically turn individual transmitters on and off to optimize the system and that type of thing. And then when we went to the convex-based system, now we generate all the PL in the convex box, and then that's sent along through the microwave, through the Harris via 40 cards. So your PL, you have a 5 to 3,000 hertz card now. You can send your PL with it, and everything goes out to all the sites. And then you don't have to generate the PL at each individual site, which also required you to go to the site and adjust the amplitude of the PL, which was rather labor intensive. Now we can optimize the whole system just from the main site. I can say regarding the convex audio distribution box, there's a lot of op amps in it and things like that. Everything that comes out of that thing, you put in one end. All the outputs are the same amplitude when they come out. All the outputs are in phase. You know, it was almost a plug-and-play type device. And then having the PL generated right there, so you can adjust everything right there. When we adjust amplitude, we find we have very small amplitude adjustments because of I think the system we use, where we use T1 and the Harris cards and everything else and the matching transceivers. We will actually do that in the Harris card itself. If you ever use the cards, you adjust the P values to change the gain basically from one end to the other. And we have very small increments that we have to do that to pull the simulcast within half or a quarter dB of amplitude matching. With this system, technicians can basically build the system, and myself as an engineer usually can optimize the system in about 1 to 2 hours once the whole system's up. This is a picture of the convex box and the switches that light up, and you're dealing with telco type connectors. We just run it over to a punch block with pre-made cables. This is the NBL4 narrowband booster limiter. I think the original idea behind this product is if you have a narrowband channel, you can put this in and it sort of do some audio processing and boost the audio a little bit. We use it in a different way in the system we have. When you use a Motorola Quantar, or the same thing in the GTR 8000, the next generation radio, you do simulcast like Motorola does. You enter it into basically a baseband input, and that takes all your stuff from 5 hertz on up, and it's going to transmit that. However, none of that has any of the normal control that would come with, say, a normal Motorola base station as far as limiting your maximum amplitude and that type of thing. So if you pump audio down the line and you turn it up, it'll go 3, 5, 7, 9 kilohertz. It'll deviate there. That particular type of control is not applicable on that input. So what we use this for is we use this to put a ceiling on the maximum amount that can go out to the Quantars, so none of them will over deviate. Now, as we worked on this, and we worked on this with Ed O'Connor, what we found out is, because of what we used it for, we really couldn't use it for the narrowband boosting part. In other words, we put a ceiling on, say you want to be maximum 4.2 kilohertz, you'd put a ceiling on there, and then, well, now you can't adjust it to do the narrowband boosting part because you're sort of using that part to put a ceiling on. So, worked with the manufacturer to come up with sort of 2 levels. One is a maximum level that can come out of the box, and the second is sort of a compression type ceiling for narrowband, although we haven't used it for that. Our experience with narrowband, we have narrowband in one of our systems, is that if you narrowband the whole county at the same time, everybody turns up their volume more. It sounds pretty much the same. They adjust to it. We haven't had to look into any kind of boosting or that kind of thing so far. So this, in this particular configuration, is almost a necessity for us, because otherwise we basically can't control the system from over deviating.
Go back to your system diagram so that we can see where that was in the
I don't know. I don't really think I had that in here. I took some old diagrams and adjust them quick, but basically that's going to go in here before you send your main audio into the convex box. Is what it's going to do. So
in between the voter and the convex?
Yes, between the voter and the convex is where it would go. So okay. So I summarize some things up a little bit, back to how, at least our philosophy on how to do simulcast. Number one thing is simulcast is complicated. What you want to do is minimize the variables. minimize the things that you have to adjust and have to change. So, we do that by basically having reliable T1 backhaul, keeping identical audio response in all the components, the Harris cards, the Quantar, that type of thing. Eliminate time delay changes, which is basically accomplished by the SynchroCast. And finally, I want to just comment a little bit on advantage of this over self-adjusting systems. There's some suppliers out there who have, I don't know, I guess you could call it the magic button or something, and they tout the ability of their system to self-adjust. They say, oh, well, you can self-optimize their system and you press a button, and basically it goes through a giant, it's like an automatic audio equalization is what it is. Sends out tones over the air or whatever, and then adjusts the system. And that sort of sometimes say, well, that's an advantage. In reality, I think that's sort of an admission that your equipment is not phase and amplitude stable. In other words, your equipment can change, your transceivers might not be matched. Makes me wonder if temperature changes as your phase and amplitude response changing over temperature and things like that. So to me, it's sort of like saying, does your Crown Vic automatically tune itself, or is there like some manual thing in there adjusting your timing all the time and doing a tune-up for you? So it's actually the other way. I think it's the other way around. We have the first system we put on the air, turnkey system, is 8 years old. It's a Harris SynchroCast3 system at the time, Motorola Quantar. Recently I went up after 8 years and re-optimized the system, but I should stop and say I didn't have to re-optimize the system. All the phase and all the amplitudes are still matched after 8 years. So it's an illusion that you have to go back and keep re-optimizing simulcast system. That's only true if you pick components that aren't stable. If you pick stuff that's stable, you don't have to do that, and you don't have to have things going out over the air and automatically re-optimized. We simplified our design with the convex and with the Harris VF40 cards. And then a couple general comments on narrow banding and other things. The Motorola Quantar has been discontinued and has been replaced with the GTR 8000. And Motorola has basically designed the GTR 8000 to be a drop-in replacement for the Quantar. This includes VF, VF24, all the strange old type digital interfaces that you had in the old days and that kind of thing, that all rolls over because they need to have a transceiver they can continually drop into the system. It also has all the same inputs as the Quantar, including the baseband input and the wild card and everything else. So the GTR 8000 can be used just like the Quantar in a analog simulcast system, the same way that we've been doing it. We were very, very encouraged. We haven't done it yet, but they're very specific that all of that is in there and all of that's available because Motorola still does their own analog simulcast systems, so they need to do that. The one thing to note is you can't mix Quantars and GTR 8000s on the same channel, meaning the GTR 8000 is phase and amplitude matched to itself, not to a Quantar. So if you have 4 channels in a system and they're all Quantars and you add a 5th channel or another site or something, each individual channel has to have all the same transceivers. Each individual channel has to be all Quantars or all GTR 8000s. You can't mix and match them in a simulcast system. But you can use a GTR 8000 to simulcast analog just like the Quantar.
Question. On the GTR 8000, are you operating it in the linear mode or the Class C amplifier mode? I don't know a lot.
It would be the normal FM mode. Yeah, I mean, it's for analog.
Yeah.
It's for, we haven't done any yet, but that's the way we would do it. We would run it just like normal FM. So I mean, the GTR 8000 is capable of the analog, or linear also, for Motorola's way of doing P25 simulcast, for example. I said a little bit about our narrowbanding experience. I mean, our experience has been, it goes a lot smoother than I thought it would as far as doing an entire county. And everybody talks about coverage losses. I mean, most simulcast systems, at least ours, we saturate the county so well you don't have a lot of low signal areas. But in the place where people were very marginal, they do notice the difference. We do get a few complaints, but that's where somebody was very marginal. And that pretty much matches up with all the math and everything else. Finally, last year, I know Ed Blaschka was up here and talked a little bit about P25 Phase 2. and said a few things about P25 Phase 2 being able to tolerate basically more delay spread, or you could say more delay than P25 Phase 1. With analog, we can have 50, 60, 70 microseconds delay and get away with it. P25 Phase 1, in the nonlinear thing, boy, you get past 10 or 12 microseconds of delay and things start to go bad on you. If you have the Motorola linear method, you can stretch it out to 50, maybe 20 microseconds. The problem is that reduces your site spacing down to, 8 miles, 10 miles, 12 miles, or things like that, and it gets very terrain dependent too, and that type of thing. So doing a P25 simulcast system in a rural county becomes a bit difficult because you just don't have the money or the capability to put in sites at that kind of spacing. Instead of having 6 or 7 sites, you could have 10 or 12 or 14 sites, and the price of the system doubles. Apparently, I don't know, in Phase 2, there's some talk that Phase 2 with the TDMA will allow a greater delay. I don't know. I'm just saying, if this is true, it sure be nice if we get some more documentation on it.
I'm going to cover that later today.
Okay. Because what that allows, all of us in here to do is to basically go in and keep doing analog simulcast and then tell your customers, well, what you really want to do is wait till Phase 2 is in, and this is for conventional systems mainly, wait till Phase 2 is in, buy Phase 2 capable radios, buy Phase 2 capable transceivers like the GTR 8000 in your system, so that when you get it's time you want to convert, you've got the same sites, and you can use the same sites for simulcasting your digital. So I'm hoping that as time goes on, we can get something more solid to go on that shows this is indeed the case. If it's not, it's not, but if it is, that'd be great. So with that, that concludes what I have here. So.